Hey everyone, happy Wednesday. Hope you're having a great time with the sub. We are still going to do some notes, so you should have a paper copy if you'd like one, or upload these notes from today's date on the calendar or Schoology into Notability. So this is Unit 1, Day 4, Multiplying and Dividing Radicals. Today we're just doing multiplication. Okay, so no division today. That's going to happen tomorrow when we're all together. But for now, we are going to do some work with some radicals. So we have already done a lot of review of exponents, of radicals, things like this. And today we're taking this a step further, learning how to multiply two radicals together. So what's my rule? I'm going to tell you the rule and then we're going to talk about why that makes sense and kind of explain what it really means. So my rule is this: numbers go with numbers and radicals go with radicals. So write that down while I kind of explain what's going on here. What I mean by this is I'm going to show you by example. So down here, I'm going to write you something like this. Let's say I had 3 square root 2, and you don't have to write this down, just make sure you get this rule down, times 5 square root 6. This basically means I have numbers, so coefficients, and I have radicals, which I'll highlight in the orange. These two things are dealt with separately. So when I say numbers go with numbers, I mean we multiply my coefficients, and then we multiply my radicals together. And I'll show you what happens when we do that. So let's go down to example number 1. I'm going to follow that rule and teach you exactly how to combine these, how to multiply them together. So I'm going to highlight first my numbers. Remember, we deal with them separately. So numbers go with numbers, radicals go with radicals. So if I just do my numbers first, what's 2 times 5? That's 10. Now I'm all done with my numbers, right? All I did was multiply. Then I deal with my radicals. That's square root 3 times square root 2. I'm going to write this off to the side. What happens here? Well, we can actually combine these. Using the rules of radicals, what happens is when we combine two radicals and we multiply them together, essentially they just go under one radical. So really this is the square root of 3 times 2, which in your mind you're thinking, okay, that's square root 6. So you don't have to show me all this work. I'm just explaining why. Basically, when you multiply radicals, they combine and they go under one radical. So here I have square root 6. And again, that's from saying, okay, numbers go with numbers, multiply my numbers first, and then multiplying my radicals together. And then they all multiply together to get us that final answer, 10 square root 6. Something you want to be conscious of here is there's a possibility that this could be reduced or simplified, right? Remember what we've been learning this week, specifically Monday and Tuesday, was that we need to use our perfect squares to double check that this does not simplify. Now, I'll tell you, there's no factors that are perfect squares of 6, right? Really, it's just 2 and 3. Neither of those is perfect squares. So we are all done here. But I want you to get in the habit of generally reducing those. Now, we're not going to do that today, but I do want you to practice that in your homework, on tests, all things like that. I will ask you to simplify completely. This is a rule of thumb, so you want to do this all the time. The only reason we're not doing this in class is for the sake of time, right? And because you already know that skill, you should be practicing it at home. And if you have questions, come to me or math tutoring. Okay? So again, just make sure you're thinking, can I simplify this? Now let's try this next one, problem 2. Remember what I said, numbers go with numbers, radicals go with radicals. Well, do I see any numbers on the outside? Technically, I do have invisible ones here, right? But if I take 1 times 1, doesn't really affect anything. It's just 1 times 1. So we don't care too much about that. Then I'm going to highlight my radicals. Well, I know what happens. If I have a radical times a radical, I just take one big one and then multiply everything underneath it. So I'm just going to write the square root of 15n squared times 10n cubed. Once I'm at this point, I can actually combine things, right, and multiply this out. So I can go further and say, well, 15 times 10 is 150, and then n squared times n cubed. Remember from your exponent rules, if we multiply two variables or numbers with exponents, then we just add the exponents together. So this is n to the 3 plus 2, so n to the 5th power. Now what you're going to notice here is think to yourself, can I simplify this? I'm going to tell you, you absolutely can. 150 will have divisors that are perfect squares, and we know n to the fifth can definitely be broken down and come out of my radical. Again, I'm not going to do that with you today because it's a skill you'll practice on your homework and throughout the lesson tomorrow. Okay, so just keep that in mind. This is able to be simplified, but I'm not going to show you right this second. So keep it in mind, and if you want to try it, go ahead and try it on your own. That's totally fine with me. But this is what we get when we multiply it out. Now let's practice some more complex examples. Okay, so I'll give you a second to catch your breath. I hope we're not going too fast, but if we are, you got plenty of time to catch up, and you can always check this out at home. So what happens here? Well, problem 3 looks a lot trickier, right? And it totally is. But that doesn't mean we can't handle it. Now, what do I see? I see 1, 2, 3, 4 terms, right? But they're all contained in parentheses. Well, what does parentheses mean? That means that I am multiplying these two things together, right? Now, when I multiply things that have parentheses, remember when I'd give you something like this, x plus 2 times x plus 1, and I'd ask you to FOIL it out. A lot of people call this foiling. You can just say you're multiplying it out, right? And what I would do is take x times x times 1, 2 times x, 2 times 1. So what you're doing is you're multiplying all the terms together in order to get 4 final terms. And then you might be able to combine those like terms and get even more of a concise answer. So that's what I'm going to do. Generally, how I'll do this, and you can multiply in whatever order you want, but I'll usually say, okay, I know because I have 4 terms here that I'm going to end up with 4 terms, right? So I got 4 spots. I'm going to take the first term times the first term. So make sure you're at the start of the parentheses here and then the start of the parentheses on the other side. Now, this is what you're doing. Basically, you're multiplying radicals like 4 times, right? So I'm going to say numbers go with numbers. 1 times 2, that's coming from these 2 coefficients, that's 2. Now, what about square root 3 times square root 5? That all comes under 1 square root, and I get 15. Okay, we don't need to worry quite yet about simplifying that or anything. What do I do next? Well, I'm going to take the square root 3 and multiply it by the second term. So now I have 1 and negative 1 as my coefficients. I'll show you these in pink. 1 and negative 1. So that means I have minus, and then I have my square roots. Square root of 3 times 3. Well, that's 9. I know that reduces. I'm not going to do anything about it yet. All I'm doing is multiplying out. Okay, I know this is getting real ugly here, but we're still going to keep going. Then I'm going to move to this term, and I'm going to multiply the 2 in the middle. So I have what? Negative 7 and 2. I'm actually going to erase some of the funky work I got going on so that this looks less scary. So I have negative 7 and 2. So that's negative 14. And again, that's from knowing, okay, numbers go with numbers. And then I'm going to take my radicals, which are, okay, I'm editing this to make sure it looks good, root 2 and root 5, which gives me the square root of 5 times 2, so 10. All right, my final thing I'm doing is taking this one times this one. So remember what we just did is we FOILed all the way across. And this thing highlighted in pink is the last one I'm doing. So I have negative 7 root 2 times negative root 3. So what are my coefficients? I'm going to highlight them in yellow. Negative 7 and negative 1. That is positive 7. Then I take my square roots. So root 2 and root 3, and I get root 6. Okay, awesome. Well, some of these are going to simplify, right? And I'll show you one thing that we want to be conscious of is these. This is a perfect square. So what's the square root of 9? That's 3. So I can actually already simplify this to 2 square root 15 minus 3 minus 14 root 10 plus 7 root 6. Now, we have already learned how to add and subtract square roots, right? Here, in this case, there's nothing we can reduce and there's nothing we can add or subtract. So I'm totally done. All right, so we actually simplified that one completely. So make sure you get all that down. And if you don't, the answer key is always up on Schoology, and you can always return to this video to check it out. So I'm going to move this around a little bit because I don't want it to be in our way for the next problem. Number 4. So all this is, if you look at this off the bat, looks kind of like you're distributing, right? That's exactly what I have to do. But it's going to cause us to have to multiply radicals. So to distribute, the first thing I'm going to do is multiply the first 2 terms. When I multiply radicals, I see no coefficients, right? It's really just 1, so we don't care for those. I take the square root of everything that's under there. So 3b times 10, which should be 30b. All right, so I'm all done there. And then what do? When I distribute, I add the second term, and that should give me a radical times a radical. So 3 times 3b is 9b. So do you think that we need to continue going? The answer is no. The reason being, we cannot combine these terms, right? Remember, to combine radicals, the inside has to be the same, and they are not. So we go ahead and leave them. Okay, so now we can move on to number 5. Last problem before you'll have plenty of time to work on a separate worksheet. This one is a little trickier, so pay attention for now. Remember, this is where we FOIL, right? I see 4 terms, so I know I'm going to have 4 big old terms in the end. Here's what I'm going to start with. I'm going to multiply the 2 outside terms, right? And by that I mean the first terms in each parentheses. So what do? Numbers times numbers. 2 times 1 is 2. Then I take the square root, and I have 2 times 7. So that's 14. Okay, second term. I'm going to do another little line and then multiply 2 square root 2. And this funky term over here. What do? Numbers come first. 2 times negative 4 is negative 8. Okay, and then radicals. Now, this is very important. What happens if I try and multiply a square root by a cubed root? Do they combine? My answer is no, they do not. So basically how you treat this is if I multiplied like x times y, you don't combine those. You keep them separate. So what I'm going to do here is just write square root 2, square root 3 of 3. So, sorry, I meant the cubed root. Now, the reason for this is they're not the same root, right? So when you notice, when I combine these first terms, they're both square roots. That means we use that rule where everything goes under one root. But in this case, they're different, so we do not combine them. Okay, and we'll see that again in a second. All right, so the third term, I take my coefficients, which are 1 and 1, so we don't care about them. We add these 2 terms. Now, when I multiply these, can I combine them? No, I can only multiply them because one of them is the cubed root of 5 and the other is the square root. Okay? And then finally, I'm going to show you how to multiply these last terms out. I get the cubed root of 5 and negative 4 cubed root of 3. Now, my 2 coefficients are an invisible 1 and a negative 4. So 1 times negative 4 is negative 4. Now here, this is interesting. I'm going to highlight this in pink. The cubed root of 5 and the cubed root of 3. Can I combine those? Yes, it works the exact same way that my square roots work, right? When I combined root 2 and root 7 in the original multiplication, I combine them underneath the radical. Same thing happens here, except it's the cubed root. And then underneath, I put my numbers. So 5 times 3 is 15. Okay? Now, you're going to notice here, there is nothing that I can further do. I have to leave this. There's no way I could further simplify, even if I asked you to. Okay? So that brings us to the end of our notes. And tomorrow, we'll learn kind of the opposite of this, which is dividing radicals. So what you're going to do now is go ahead and head to the course calendar. And right underneath our notes, right, says Multiply Radicals Worksheets. This is a very long worksheet. You do not need to complete all of it. But what I want you to do is work with the people right next to you. Feel free to chat at this point and talk about these problems. I want you to practice these. there's already an answer key attached to the bottom of this worksheet. So there should be 2 pages of problems and then 2 pages of answer key. There's a ton of problems, so skip around as you feel is fit, okay? And make sure you remember these radical rules, and we'll talk about any questions you have tomorrow. Okay, so that's for the rest of class. Now, this will not be homework, but I expect you to work on this until the end of class, and then tomorrow's homework will review multiplying radicals. Okay, so the rest of class, you're working on multiplying radicals worksheet with your friends in class, and I will see you tomorrow.